You would set it, you would set it equal to, actually, wouldn't you add 7 to the end of the equation, then equal it to 0?
Nope, just
It's
the original.
above
Nope,
7.
nope. You just find the vertex of this. Just the
All right,
vertex
then
of
you would
this.
set it equal to 0, then complete the square to get vertex form. Take the h and k from the vertex form. So you would do negative t squared plus 8t equals 0. You do negative t squared plus 8t plus so
That we're talking about, I guess we got to show the work. Well, I guess you show the
yeah.
equation here, minus b over 2a. So minus b over 2a.
So we do minus 8 over -2, but -1 would mean that would be it would be x equals 4 for the negative b over 2a.
So that's the x value.
Yeah,
We want the y value. So the y value
so you
you
have to
get by
plug it
putting,
in.
yeah, back into the original.
-4 squared. I got 48, so 4 comma 48.
So it's minus parentheses 4 squared plus 8 times 4. My guess is you put that negative inside there. The equation really has parentheses around the variable.
Got it. So in that case, it would be this. All right, in that case, it would be 4 comma 16.
Yes, but we just want the height. It just asks for the maximum
Yeah.
height. So you just want to give the maximum height as
So
the
in that
answer.
case,
You would
that,
say
yeah,
the max height is 16
meters.
meters. Although, does it give units? Yeah, it does. Okay. Okay. Now for the next part, that's where the 7 comes into play. We want to know where the equation, and we're running out of room here. It's where's the equation greater than 7? So the next, so what you really want to do is figure out, well, where does it equal 7? Where does it equal 7? All right, so this is where you move the 7 to the other side of the equation, or you could actually move the t squared to the other side of the equation, which is probably preferred because then then the leading term is positive.
Got it.
So it'd be like when you move it to the other side
Yep, so
here,
you
it's
get
t
t
squared
squared
minus
minus
at.
8a. Yeah,
Yeah.
plus 7. So yeah.
And yeah, it's 0 equals, but you can move that equals to the other side. And then this you can factor.
Would be, oh, yeah, right. Yeah, to -7 and then -1. So need to, but if you were to solve them, it would be t equals 7 and t equals 1.
So those are the two t values, t equals 7 and t equals 1. That's where, it first is above and then below, it goes up above 7 and then, so you don't want to say that. You want to say after 1 second and before 7 seconds, the ball is above 7 meters.
Got it. Mm. Okay.
All right, so that's it for part B. Part C, let me know when you're ready for us to talk about that.
Um, mm, Wait, how do you get the 1 second again? Like after 1 second before 4 sec before your second?
You, you're setting it equal to, you're
Oh
setting
yeah,
the
yeah,
two,
right.
two of these equal to 0. So
So you
like
just equate it to zero.
it's one
Okay.
on the way up and then one on the way down.
Okay, got it. Then for part C,
So for part C, it's decreasing when it's on the way down.
so it's only talking about the decrease, or what is the
Yeah.
time interval
So
of
so
a
so that's where it's the vertex, from the vertex to wherever it hits there on the ground again. So we need to figure out where the original function equals 0. Where does minus t squared plus 8t equal 0?
yeah, then you would equal to 0. Got it.
So to do that, you factor out a negative t from
T,
both.
yeah, that gives you negative
Negative
t equals
t,
0
yeah,
and
you
t
set them
minus 8
both
equals
equal to
0.
0.
So you get
So you
t
get t,
equals 0 and t equals 8.
right? So when you go back to our picture, we know, yeah, it's 0, it's there, and 8, it's there. And we already found this middle value of 4. So from 4 to 8, from 4
4 to 8
seconds,
to 8 seconds.
8
It's decreasing.
seconds, it's decreasing. Yeah.
Got it.
Okay. That is everything for this problem.
Here's the next one, which
All right, there it is. Now we didn't fill out the lower left and the lower right. I mean,
yeah, that's
I don't,
kind
I
of
don't,
straightforward because that's
I
just
don't
the
like
answer
this.
from.
Yeah, I don't like this, but yeah, make sure you
Yeah, most
like
of
the
them are just
variable.
straightforward with the variables. For example, for like if it's time, then it'd be, for example, for the next question, it's h. That would be h is height of the ball in feet,
Right,
and t is
exactly.
time in seconds. So
All right, so this one is find the highest point that our golf ball reaches and how long it would take to hit the ground again. This one's actually a little bit easier than the previous one. So it, hits the golf ball, goes up, goes down. Highest point is the vertex, and how long it reaches the ground is there. So why don't you find the vertex for us, please? Both coordinates.
all right. So the vertex 100 is-
You have an answer for me on this?
um, I'm finding the y, right?
Yep, got to find the y value. That's the actual height.
I got about 156 feet, or,
Yep.
to 160, 156
Now,
feet.
if you're using a calculator, you ought to give the exact answer.
So
Because
156.25.
yeah, because that's maybe something to think about is maybe you know, be careful there that you don't round when you don't have to.
Kind of.
All right. The That's the vertex. So the sentence, sometimes the sentence can be confusing, but you just include the words. You can say the highest point that the golf ball reaches is 156.25 feet. Which is actually very high for a golf ball. Professional golfers are about 90 feet. You occasionally something as high as like 130. Very rare. Go even that high. That's maybe impossible, practically impossible. Okay, now this next one right there, how long it take to reach the ground, again, that's setting the equation equal to 0.
Equal to 0, you would get
You can factor out like what? You can factor out 4 from both, a minus 4t from both, and that gives you 4t minus
Oh, right.
25.
1 second. I forgot the t from the hundreds. Let me redo it. 16t squared plus 100t equals. Yeah, you can take -4. Or I can have 4t, yeah. You
Yep.
can take t. So that's t. I got t equals 0 and t equals 25.
It's 25 over 4 though.
Sure, 100 divided. Yeah, so yeah, it would be 25 over 4. So then that would be here. So x equals 0 and t equals 25 over 4.
Yep.
Yeah.
Yep. So that is the answer. That's how long does it take to hit the ground? 6.25 seconds. That's your answer there. Any questions on that? Thoughts on that?
Yeah, good.
There's really only a couple of things they ever ask you about on these questions. They either ask you about the vertex, which could be the X or the Y. They ask you about this point over here. And then we saw in the previous problem, sometimes they throw a number that they want you to see if it's like above or below. What'd you like to look at next?
Yeah, I have here. Let me. So that was the day one of quadratic applications. Good day two. Okay, this is kind of like number. This is number three on the day two of quadratic application. I go over the in the chat. All right, it's in the chat.
Oh boy, there's a lot here in this one. Let's take a look. Okay. Well, yeah, I mean, it's just a bunch of questions here. So, uh, how long is the rocket in the air? Okay. So that like you're trying to decide, is it an X value? Is it a Y value? Where is it on the graph? What do you think here? How long is it in the air? You can actually tell just from the graph. You don't need the equation.
9 seconds.
Okay. Where are you getting 9 from?
We actually, and
Right? It hits the ground at 8.
so it's 8 seconds. So it starts from zero. So it's thrown from zero to
Yeah.
150. So
All right, now what is the greatest height of the rocket? So this one's where you got to be a little bit careful here. Like it's right there, I guess. Like that's the greatest height. But is that, exact? Maybe it's better to use the equation for that. Now, I think it says to look at the graph to do it. Because here in G it says to use the equation. Um, so I think you can actually just read it off there. Like each of these grids are 10. So to me, it looks like it's 260. But again, that's not exact. Do you think your teacher wants exact here?
um, here I'm not sure if we didn't go through this day of it yet, but
But it's because it says
Probably.
like look at the graph, and then like down here it says to use the equation, but it doesn't say to use the equation here. Um,
Yeah, I think that one doesn't, because the other one says find the exact value of it. The other one
yeah, because
doesn't,
because
I
the
don't
because
know.
the exact value is actually 256. Um, so I'm not sure. I'll just maybe put 256 here for you to think about later on. Um, that's the exact. Part C, about how high is the rocket after 1 second? So again, you could do this exactly by going to the equation, but it says about. So you're really just supposed to go to the graph, go up here, hit right there at 1. It's about 100. And then we need units, feet. We need units in the previous one as well. After 2 seconds, about how high is the rocket? So 2 seconds, boom, we go up, hit, let's say it's about 190 feet. Is the rocket going up or down? If it's going up, if it's going this way, it's going down when it's going this way, rising, falling, like that. All right, so see if you can fill in letter E.
For E, it's 190 and it's going down.
Agree. Okay, it says, do you think the rocket is traveling faster from 0 to 1 second or from 3 to 4 seconds? So the way to answer this in full disclosure is to look at the steepness of the curves. Which is steeper, that part of the curve or that part of the curve? Like, think about hiking. Like, if you were to hike, which would be easier to hike? Which is, or which is harder to hike? The steeper one is harder to hike. Maybe don't hike. Um, this one is steeper here in the beginning, so it's going faster.
Okay.
And you want to say something about it being steeper, deeper. All right, using the equation to find the exact value of the height at 2 seconds. So to do that, you're going to put 2 in for t. We're just using the given equation there. If you want to do that, let me know what you come up with.
I got 192.
Right? I agree. All right, so the domain is always the x values. For
So
what x
it's
values is this good for?
uh you can from zero so zero bracket
When does it hit the ground?
to eight bracket
Very good.
because it's not arrows, and it's filling, so
Right. It can be 0, it can be 8. That's right. The range is the y values. You really need the vertex to do it. I kind of already did that for you. So for part I, I'll just make a note over here. You really need the vertex, which is 4 comma 256. So in this case, it would be 0 to 256 because it starts on the ground. That 0, 256 is the maximum value. All right. Increasing is when it's going up and to the right. These are both going to be open intervals. Since we're running out of time here, I'm just going to give you the answers here. It's 0 to the vertex, and then 4 to when it hits the ground. And this is when it's going up. This is when it's going down, like that.
got it.
Right. Probably as good a place as any to stop for today.